Okay, so when we talk about matrix, we are looking at a rectangular array of numbers or expressions, and the organization is in rows or columns. So mostly it is rectangular. Just a few of them are square matrices. So if it is 2 by 2, it's a square matrix. If it's 3 by 3, it's a square matrix. Apart from that, the once we have our rectangular arrangement of numbers or symbols or expressions or anything, and it's organized in rows and then columns. So classrooms is an arrangement that can be a form of matrix. So any arrangement that has to do with rows and columns, we can look at it as what matrix, and it helps us to solve problems. Okay, so let's take an example I have here. We want to express the information of possession of pens and pencils by um you and then your two friends. Let's
Okay,
see.
so are you right? So are you
No,
writing?
I'm not writing it. So I'll
Oh, okay.
just express the possession of pens and pencils by you and your two friends. Okay, which are as follows. So you have two pens,
So are you writing?
I'm not coming to write,
So like right, I want to see if I can see your screen.
or you'll be able to see.
Mm.
Can you see now?
So
Can you see?
so
Okay, so let me use Achu. And what's the brother's name?
Edu
Edward.
EDOH.
Okay. So Echi has two pens and then seven pencils. Achu, you have one pen and five pencils. Then Edu has three pens and then two pencils. So when you have this and you want to write it in a matrix form, so we can have the arrangement of the pens and the arrangement of the pencils. So if it's in order, HA two pens, Achu one pen, Edu three pens. And the pencils should be at the other side, seven pencils for HA, five pencils for Achu, and then two pencils for Edu. So when you put it together like this, that's a matrix. It can be arranged like that, or you can put it in brackets like I'm doing. So two, one, three, then seven, five, two. And that is matrix. So you see, we've arranged the pens and then pencils in rows and column. So if you watch carefully, if you are moving from left to right, the horizontal arrays are called rows. So what are the rows here?
The three rows.
Come again.
So we have three rows here.
Yeah, so 2 7 is row one, 1 5 is row two, 3 2 is row three. Then, so what is the rows telling us? It is telling us the stationaries that each of them is having. So the first row is for HA, second row for Achu, third row for Edu. But if you are looking at the columns, then the columns is really categorizing them into pens and then pencils. So when it happens,
Yeah.
this is it. But then, so if you want to name this matrix, you always read the row before the column. You always read
Three
the
by two.
before the column. So obviously this is going to be a 3 by 2 matrix. So always if you are reading the matrix, the rows comes first before the columns. So it has 3 rows and 2 columns. So in that case, it's a 3 by 2 matrix. So that is it for the matrix. So the horizontal arrangements are called rows, while the vertical ones are called columns. So let's look at types of matrix. As I said, we have a square matrix. For square matrix, it should be 2 by 2 or 3 by 3. If you have 2 by 2 or 3 by 3, it's a square matrix. Then we can also have a rectangular matrix, which can be in any form apart from 2 by 2 and then 3 by 3. So if I have a 1 by 2 matrix, that is going to be a rectangular matrix. If I have 2, 3 here. What matrix is this?
1 by 2
Yes, and this is
matrix.
rectangular. If I have this matrix, what matrix is this?
2 by 3.
Okay, 2 by 3. So 2 by 3 matrix is also a rectangular matrix. So how about this one?
So 2 by 2.
So that's a square matrix. Okay. So we have zero matrix. So for zero matrix, it means that the rows and columns are going to be zeros. So you can have a 2 by 2 matrix, that to be zero matrix. And that will be 0, 0, 0, 0. 2 by 2 matrix, that's zero matrix. And this is 1 by 2, zero matrix. 2 by 1, right? Zero
Mm,
matrix.
so,
3 by 3, zero matrix. So anywhere, anytime matrix has entries which are all zeros, then we call it a zero matrix. Okay, I'm going to give you three matrices right now. You will tell me which of them is a zero matrix. X minus x, 0, 0, negative b plus b, and then 0, 0. This is matrix A. Then you have matrix B, 1, neg 1, 0, 0, 0, 0. Then you have matrix C, which is m minus m, 0, 0, 0. So you have these three matrices. Now, which of them is a zero matrix?
ah, see.
Yes,
So A and C. Or
yes, A and C. Because the x minus x is 0, and like b plus b
yeah.
is 0, and the m minus m is
Yeah.
also 0. So once the entries are all 0, then that's a zero matrix.
Okay. So for zero matrix, all the rows and columns must be zero.
Yes, all entries are zeros. All entries are zeros. If there's even one entry which is not zero, it is not a zero matrix.
Okay.
Let's look at unit or identity matrix. That one is a special type
Uh,
of matrix. Come again.
so no.
Okay, so that one is a special type of square matrix, okay, which is having um every non-main diagonal element to be 0. I will have the main diagonal element to be equal to 1. When I say
So,
main diagonal element, I'm looking at principal diagonal from the top left to the down right. So if I have a 2 by 2 square matrix like this, so if you watch from the top left to the down right, that's the principal or the main diagonal. And everything on the main diagonal is 1. Whilst the others, that the non-diagonal is giving you 0 entries. So anytime you have a square matrix such that the main diagonal has entries of 1 and the non-diagonal entries is also 0, then it means that that type of matrix is a unit or identity matrix. So if we take 3 by 3, then we can have it as 1, 0, 0, 0, 1, 0, 0, 0, 1. 1, 0, 0, 0, 1, 0, 0, 0, 1. And this is also a unit or identity matrix. Is that okay? How about this?
Okay. So no.
Mhm. So the other diagonal, we are not interested in other diagonal. It's the main diagonal we want. Top left to down right. So this one is
Okay.
a unit or identity matrix. Now let's look at equality of matrix. When two matrices are equal, then their entries are also equal. Okay, so if I
Mm-hmm.
take A, B, C, D to be equal to E, F, G, H. Once they are equal, then their entries are also equal, such that top left and top left are equal. So A is equal to E, down left and down left will also be equal. C equal to G, B is equal to F, D is equal to H. So if matrices are equal, then their entries, which are corresponding entries, are equal. So that's how you should know it. So let's take an example of how to work around that. So we have matrix P to be equal to 3 over 2 x, y minus x, and then negative 3. That's our matrix P. And our matrix Q is equal to x 1.5, 3.5, negative 3. That's our matrix Q. These are two equal matrices. You are finding the values of x and y. So we are finding values of x and y. So what's x, what's y? The ball is in your court.
So X is 1.5.
X is 1.5. Okay. How about y?
So I'm coming. So 2.
Nope.
So I'm coming. Y is equal to 3.5 plus 1.5. That's 4. No,
That's
5.
5 years. That is it. Okay, so let's look at determinant of a 2 by 2 matrix. Determinant of a 2 by 2 matrix. So if you want the determinant of a matrix, sometimes you call it the matrix. So if this is A, so you can say that A. That means you have to find the determinant of A. It's very simple. The determinant, let's say I have matrix A to be A, B, C, D. If I want the determinant, it's a product of the leading diagonal minus product of the other diagonal. So in that case, the depth A here becomes A times D. That's our leading diagonal minus B times what? C. That's our other what?
So what the A times D is what?
Z.
So A times D is what? So you mentioned, wait.
Come again.
So what is A and D? You said something diagonal.
Yeah, I'm saying that's the principal entries along the principal diagonal.
Okay.
Mhm. So the entries along the principal diagonal minus the entries along the other diagonal. That is how to find a determinant of a 2 by 2 matrix. So if I have the matrix 21, 17, 4, 9. What is the determinant of this matrix B?
Um, that's 21 times 9 minus 4 times 17.
Okay, so what's the answer?
18 minus 24. One. So 121.
Okay. What is the
So come
that's right. What's the determinant of what I'm writing?
on. So that's A plus 3.
Yes.
And 8, 7. I'm getting A squared plus 21.
Okay, that's right. Sometimes they wouldn't write the determinant, but you see it in bars, like the way it is in magnitude in vectors. Okay.
Yeah.
Sometimes it can be in that form. Don't forget, it also means determinant. So let me take a question of that nature and let's see. So let's say find x in this for -2, 3x +5, and that should be equal to 32.
So 20 minus 26. So X is 2.
Okay, that's right. So let's proceed to something else. Now, other questions, you practice them later. So let's look at how to add and subtract matrix 2 by 2 and 3 by 3. Or okay, your scope is 2 by 2. So if I have A, B, C, D as a matrix, and I am adding that to E, F, G, H, what would that be? You have to add carefully, top left, down left, top right, and then down right. So when you're able to add this up, then that gives you the addition of the matrix. Okay. So this one also be examples. I know you can do it. If it's subtraction to then do
Mm.
the same thing. I'll send you some example
Okay.
to practice. So that's the addition and subtraction. We would not waste time on that one. So let's go to the next thing, multiplication of a matrix. So if I have matrix P to be 4, -1, 2, and I'm asked to find -5P. So it means I'm going to multiply -5 by the matrix. Therefore, -1, 2, 3. So in that case, what happens is that I multiply each of the entries by -5. Is that okay? So -5 times
Yes.
4, 20, -5 times 2, 10, -5 times -1, 5, -5 times 3, 15. And that gives me -5p.
So this one is like multiplication by a scalar.
Yes, the same as multiplication by a scalar. So each of them, the components take the multiplication. So
Okay.
let's and now let's look at how to multiply two matrices rather. So if I have
Okay.
one, let me use the letters A, B, C, D, multiplying E, F, G, H. And this one, you should be very careful about how to multiply. Watch how it's going to be. Always with the first matrix, you take the row and you multiply it by the
Cool.
columns. Are you okay?
Yes.
Okay, so what it means is that the first particular one is going to be A times E plus second times the down, B times J. And that's the first entry of the multiplication. So if you want to come down, then you take the row and then the column. Is that okay? Is that okay?
Yes.
You take the row and the first column. That's what to come down first. So it will be C times what? E, right?
Yes. Yes.
Plus D times what? J. Then if you want to take this side to this, and then you take the other one, A times F is what? AF. B times
Yes.
H is what?
AF DE
H.
plus DE.
The last one will be what?
CF plus DH.
CF plus DH. That's it. That's how to multiply a 2 by 2 matrix. So you should just take note of that. And because of that, it means that if I'm multiplying the first by the second, the answer will be the same as second by first. If it's second by,
Come again.
if I'm multiplying this one, let's say this is A, this is
Mhm.
B, means A times B would not be the same as B times what? A. The reason being that if it's A times B, A comes first. And once A comes first, we are taking the rows of A and the columns of B. If it's B times A, B comes first. It means we are not going to take the rows of B and the columns of A. So the answers will not be the same.
Okay.
You understand?
Yes.
Okay, so now to skip um I think that's what you have to know in Form 1. We are done with the Form 1 now. So the matrix they are asking to be, and then that's it. I'm done. So the rest is for us to practice. I'm going to send you a lot of questions for you to practice tomorrow.
Okay.
Then you send them to me. Or if there's any difficulty, you just draw my attention. If there is none, then it means you have cleared matrix.
So what of invest something?
I'm sure it's going to be informed too. I'll check
Mm.
the you know what? I'll check your curriculum and send you a snapshot of it. Even the calculus cry, the form one, the one is different from the form two one. So generally it means that what you have done today or right now